Chapter 14, Segment 2. The basis of the genetic basis of olfactory receptors. Linda Buck and Richard Axel were two people who studied this, and they found that the mammalian genome contains between 1,000 and 2,000 different odorant receptor genes, and this is the largest gene family known in mammals. In humans, the OR genome contains about 1,000 genes. The proportion of pseudo genes is 60 to 70%. This high proportion is due to the evolutionary trade-off between vision and olfaction. So in Old World primates have about 30% of OR pseudo genes. And most New World species have a lower proportion of about 18%. And they found a correlation between the trichromatic color vision and a higher proportion. But there is lots of individual variety in olfaction reception. This reflects which genes are expressed as functional receptors and how many copies of a specific receptor a person has. The more copies of a specific receptor you have, the more sensitive you will be to certain odorants. The number of particular receptors people express influences their liking for an odor. So when it comes to food, the more intense our perception of the retronasal aroma, the less we consume. And the physiological factors mediate our food consumption as well. Heavy alcohol consumption tends to impair olfactory sensitivity, but having only one drink, so if your BAC is less than 0.06, that improves olfactory acuity. Marijuana also improves olfaction acuity, because it activates endocannabinoid receptors that are increased. Smell sensitivity and induced greater food consumption in mice. The feel of scent. Most odorants stimulate the somatosensory through polymodial nociceptors inside the nose, mediated by the trigeminal nerve. From chemicals to smells. Theories of olfactory perception. So the shape pattern theory contends that odorant molecules have different shapes and olfactory receptors have different shapes, and an odorant will be detected by a specific OR to the extent that the odorant molecules fit into the OR. So when given an odorant, a particular pattern is generated across the glomeruli. So scents are detected by means of a combinational code. One odorant may bind to several different receptors, and one receptor may bind to several different odorants to varying degrees. So this is saying that different scents activate different arrays of olfactory receptors in the olfactory epithelium, producing specific glomerular activity in the olfactory bulb, and this determines what scent we perceive. So the next theory is the vibration theory. This is that every odorant has a different vibrational frequency, and that molecules that produce the same vibrational frequencies have the same smell. This doesn't explain though. No. So the next one is specific anesmia. And specific anesmia is the inability to smell one specific compound, and this is usually due to the faulty odorant receptors, interactions, or the lack of specific ORs. 20 to 40% of the population has specific anesmia to androstenone. So stereosomes are molecules that are mirror image rotations of one another. They contain all the same atoms but smell completely different. So this is a strike against vibration theory, because if if they were exactly the same, vibration theory says that they should smell the same, but stereosomes can smell completely different. The importance of patterns. Each type of olfactory receptor responds to the structure of certain molecules only. A molecule may have features that stimulate several different receptors. The intensity of an odor changes which receptors will be activated. So patterns are important for odor processing at early stages in the olfactory cortex. Specific patterns of activity are produced by specific odors in the piriform cortex, and odors that are perceived as smelling similar produce similar patterns. So now the question is, odor perception synthetic or analytic? Almost all olfactory stimuli in the real world are mixtures. So auditory mixtures provide an example of analysis, because the high note and low note played simultaneously can be analyzed out of the mix. And color mixtures provide an example of synthesis, because mix red and green lights and you get a yellow light. So the answer is odor perception synthetic or analytic? The answer is both analytic and synthetic. Analytic qualities are evident in binary rivalry. So binary rivalry is when two odors are presented, one to each nostril. We alternate our ability to smell one or the other, but the stronger image tends to dominate. So although we are capable of discriminating thousands of different odors, intuition tells us that most mixtures are perceived as unitary wholes. So take a rose, for example. Roses tend to be a mixture of a couple of different chemical compounds, but we only smell it as rose. So the olfaction is primarily a synthetic sense, but a certain amount of analytic ability can be developed. So olfactory white is the smelling equivalent to white noise. So in white noise, various mixtures of many different frequencies are perceived as sounding like meaningless buzz. So in olfactory white, at least 30 odorants are presented of equal intensity, they produce a resultant odor percept that is the same as every other mixture of 30 odorants meeting the span and equivalence in intensity criteria.